Welcome to this video on the question, why does a dielectric increase capacitance? And here we're specifically analyzing this with Gauss's law. So here I have what we talked about in a previous video about conceptually and semi-quantitatively, why does the dielectric increase the capacitance? And we found that it reduces the electric field. Reducing the electric field reduces the potential needed to hold the same amount of charge. So if I look at it from the perspective of Gauss's law, I have enlarged the plates over here. We see that we have the charged capacitor plates, and then I have a dielectric on the inside. And I'm going to focus on the region close to the positive plate. So we get some sort of net amount of polarization that would occur. So I'd have some negative charge that would polarize here. Now, it's not necessarily going to be the same exact amount of polarization from the conducting plate, because remember, this dielectric is an insulator, and so the polarization is occurring in local areas rather than occurring over the entire dielectric itself. So using Gauss's law, remember, we have to make a Gaussian surface. So I'm going to pick a point and a line, I guess you would say, across this entire region over here and enclose some charge. Now, if you imagine the dielectric not being in here, I would only have enclosed the positive charge. But now, because there's a dielectric and it's caused some sort of polarization, I've enclosed some positive and some of the negative charge from the dielectric. So I'm going to go ahead and write the information about the flux, Gauss's law, if it was no dielectric, right? And we would have that the integral E dot dA equals the Q enclosed over epsilon naught. Now, electric field along this line would be constant. Imagine this happening without the dielectric, of course. So I'd be left with E times A, and then I multiply by epsilon naught on both sides, and I see that I have a certain amount of Q that's been enclosed. Now, with the dielectric there, the amount of Q enclosed is actually going to be a little bit less, right? And so what I would show here is that the difference would be that I have the certain amount of Q that was originally enclosed minus the amount of Q that was added by the dielectric, and I have something that looks similar to this. Okay, so the original electric field could be written as Q over epsilon naught A, but the new electric field, when the dielectric is added, would be the original Q on the plate minus the Q that is caused by the polarization over epsilon naught A. So we can see that there's going to be a difference here, and this is going to be less than it was before. So it's showing that the electric field has decreased. So one way to write that in a slightly different form would be to say that this new electric field is equal to the original electric field divided by the dielectric constant, which would basically just show this. So we show the new amount of field that's been left over because of the dielectric causing some sort of polarization. So if you want to write Gauss's law for something that has a dielectric involved, what we would need to do is say epsilon naught times integral E dot dA, but now I'm going to add in the dielectric constant to this side, and this is going to equal the amount of enclosed charge. Now, all I've done that's a little bit different is I've moved the epsilon naught from being in the denominator here over. But the main thing to notice is that we've factored in this dielectric constant here into Gauss's law through this process. And the reason that it's listed inside the integral is because it's sometimes not constant itself. So even though it's called a dielectric constant, we really could be showing that at different regions within the dielectric, it might be slightly different. This is not a super new concept, right? It's just trying to show that you can use Gauss's law to show that the electric field is decreased by the fact that when you enclose the charge, now with the dielectric, you've actually reduced the amount of enclosed charge, thereby showing that the electric field is weaker. This expression just shows it in terms of the dielectric constant in Gauss's law, but it is not something that needs to be completely memorized on its own.